Hello students, welcome back to Mathematics Lovers Club. Today, Vicky is with us and he wants to ask some doubt, but that is not from Vedic mathematics. He wants to ask some doubt from Edexcel IAL Mechanics 1. So let us see what is his doubt. Hello sir, today in class, my teacher started with the constant acceleration equations, that is equations of motion or SUVAT equations, and she has given a problem to solve. I tried it, but I was a bit confused. So, will you please help me in that? Sure, Vicky. Please send me your problem and we'll discuss it on the board. Yes, sir. This is the problem my teacher has given me for practice, and I tried it, but I don't know how to do it. So please help me in that, sir. Yes, Vicky, let us do it. I'm giving you a simple hint. Whenever there is a problem on either SUVAT equation or any problem that looks to be long, what you do is keep a pencil or a marker in the hand and mark the important words in the problem. So let us do that. Now, so let us read the problem carefully. It is said that a racing car is moving along a straight horizontal track with constant acceleration. There are three checkposts, P, Q, and R. On the track, PQ is 48 meter and QR is 200 meter. The car takes 3 seconds to travel from P to Q and 5 seconds to travel from Q to R. Find the acceleration of the car and the speed of the car as it passes T. So Vicky, these are the important words. But there is a key word in this problem. Can you tell me which one is that, which tells you which method to be used in this problem? So, isn't it constant acceleration, which tells us that we have to use SUVAT equations or the constant acceleration equations? Because SUVAT equations can be used only when the acceleration remains constant throughout the motion. Great, Vicky. That is really nice answer. So, let us first draw a rough diagram here. So this is a straight track and the car is moving from P to Q and then to R. So suppose this is the car and it is given that the distance between PQ is 48 meter and the distance between QR is 200 meter and the car takes 3 seconds to travel from P to Q and 5 seconds to travel from Q to R. And we have to find the acceleration of this car and the speed of the car as it passes through T. So Vicky, first let me ask you how much you have tried and what are the steps you have taken. So here I have first considered the journey from P to Q. The displacement 48 meter is given and the time required is 3 seconds given. So what I've done is, for the journey from P to Q, S is 48 meter, T is 3 seconds. So let the initial velocity be u, that we have to find out, and acceleration a, that is also what we have to find out. Now since s is given, t is given, u and a we have to find out, I use s is equal to ut plus half at square. So 48 is equal to 3u plus half into a into 3 square, that is 9. Now to get rid of the denominator, I multiplied throughout by 2 and that gives me 96. That gives me 96 is equal to 6u plus 9a. So this is one equation. And then what I did was, I tried to write one equation for the journey from Q to R. But there I got stuck up because I don't know what is the speed of the car at Q and even at R. So I could not write any equation. Yes, Vicky. Up till here, the steps you have tried are really very nice. Nice try. But your mistake was, you tried to write the equation for the journey from Q to R, because then you have to take one more variable for the initial velocity at Q, and then you will have 3 to 4 variables which you won't be able to solve, because 2 equations will be there and there will be more than 2 variables. That will be a confusion. So in this case, what you do is, instead of taking the journey from Q to R, take the journey from P to R. Now, for the journey from P to R, we have total time T. So first 3 seconds and then 5 seconds, that is 8 seconds. Now the total displacement is 48 plus 200, that is 248 meter. And now see why I'm taking the journey from P to R, because the initial velocity will remain the same and obviously the acceleration is same throughout the journey. So now you write, again use S is equal to ut plus half at square and write one more equation that will be 248 is equal to, now in this case t is equal to 8, so you'll get 8u plus half into a into 8 square. So 248 is equal to 8u plus 32a. 8 square is 64 divided by 2. That is 32a. So I am getting the second equation. Now consider these two equations. You have two variables and two equations. So just solve them simultaneously. And obviously here, instead of wasting the time in showing all the steps of simultaneous equations, you can just solve these equations on your calculator, since your calculator is allowed here. So the two equations are 6u is equal to 9a, 6u plus 9a is equal to 96, and the other equation is 8u plus 32a is equal to 248. Now if you solve this simultaneously, you get a as 6 meter per second square. So the constant acceleration of the car is 6 meter per second square, and you get 7 meter per second. That is the answer in part B. This is your part A answer, and hence the speed of the car at point P, as it passes through point P, will be 7 meter per second. Vicky, are these steps okay with you? Yes, sir. I can understand what was my mistake. So instead of taking the journey from P to Q once again, Q to R once again, I have to consider the total journey from P to R, so that I get two equations in two variables, which I can solve very easily. Thank you, sir. Yes, Vicky, that is correct. So, in between, with Vedic mathematics, we'll take some of the questions from different modules of IAL, Edexcel IAL, as well as CIE. And I will see you very shortly. So just revise these concepts, Vicky. See you soon.